Hello everyone, in this lecture we will see about knowledge based agents. So in previous sessions we have studied different types of agents: simple reflex, goal based, model based and utility based agents. But those agents mainly reacted to what they perceived in that moment. A knowledge based agent, on the other hand, it maintains a model of the world that it continuously updates. So it doesn't just react, it reasons, infers and learns from what it knows. So here by end of this you will be able to describe how these agents work, how reasoning is performed and how knowledge is structured in such systems. Okay. So what exactly is a knowledge based agent? So it's an agent that uses a knowledge base, that is KB, a repository of facts, rules and logic, and an inference engine to make decisions. So this means the agent doesn't just act based on raw sensor input. Instead, it interprets that input using its stored knowledge and may even derive new conclusions through logical inference. So think of a human detective. He sees a broken window. He knows from past experience that this might mean a burglary, and he reasons no valuables are missing, so maybe it was just an accident. So that's how knowledge based agents work in AI: observing, remembering and reasoning before acting. So to demonstrate how a knowledge based agent works, we use a classic AI example, that is the Wumpus world. So imagine a grid-like world. Some squares contain pits, and if the agent falls in, it dies. One square has a dangerous creature called the Wumpus. If the agent enters that square, it's been eaten. One square has gold, the agent's gold, that is the agent's goal. Okay, the rest are safe, and the agent's task is to navigate safely, find the gold and exit alive. So this world is partially observable, non-deterministic and highly dangerous. To survive and win, the agent must infer where the Wumpus and pits might be based on indirect clues. So this is where knowledge becomes essential. Next, Wumpus world using the PEACE framework, which stands for performance measure. So how do we evaluate the agent? So in this case, did it find the gold, or did it survive, and did it take the shortest path? And this is and then environment, the grid world filled with pits, Wumpus and gold. And then actuators, the agent can move left, right, forward, turn, shoot an arrow, pick up gold or climb out. So this case of actuators. And then sensors, the agent perceives nearby sensations. So stench if Wumpus is near, and breeze if a pit is nearby, and glitter if the gold is in the current square. And also bump if it hits a wall, and scream if it kills by the Wumpus. Kills if it that is, if it kills the Wumpus, there is a scream. So here this PEACE framework, which helps us systematically define agent environment, something we'll use often when designing your own intelligent systems. Okay. So reasoning in the Wumpus world. So how this reasoning works in this environment? Suppose the agent enters a square and detects a breeze. It now knows that at least one of the adjacent squares may contain a pit. So if it then moves and no breeze is sensed, it can infer something more. Maybe the pit is not in a certain condition. So this is the inference. The agent uses logic rules like, if breeze is perceived, then one or more adjacent squares may contain a pit. If no breeze is perceived, then adjacent squares are pit free. And this is where a knowledge based agent shows its strength. It doesn't just react to inputs, it builds a mental map of what's likely to be true. So the agent in the Wumpus world receives inputs in a structured format, that is a 5-symbol percept list. So each position in the list corresponds to a type of sensory information. So first is the stench, second breeze, third is the glitter, fourth is bump and fifth is scream. So if the agent perceives a stench and breeze but nothing else, the percept will be stench, breeze, and then everything other three will be none, none, none. So this structured input allows the agent to apply logical rules and pattern matching to determine what it believes to be true in the environment. It's like a detective who collects clues from the scene and updates their understanding after every observation. Then across these, we will see how the agent explores the Wumpus world step by step. So starting from a safe square, observing the percepts, and then marking dangerous or uncertain squares based on the inference. Then it will choose the safe paths based on its internal model. So here this will reinforce the agent's reasoning process. After each move, the agent updates its knowledge base and infers new facts, which will be include which squares are safe, where the Wumpus likely is, whether to shoot the arrow or to avoid a risky path. Okay, the emphasis here is on progressive learning. The more the agent explores, the smarter its decision become. Okay. So here this will direct you to an interactive simulation. The simulator allows you to play as the agent and sees how the percepts are received and how decisions are made. You can try this. So this exercise is not just for fun. It helps you experience how knowledge, uncertainty and reasoning come together in a cognitive agent. Okay, so you try to pay attention to how much you can infer just from indirect sensory data. Okay. That is, it's a hands-on way to experience how logic underlies intelligence. So here finally what we have learned from the Wumpus world and knowledge-based agents is that we can represent the general knowledge about the environment using rules and facts. The agent can gather evidence from its environment through perception. Using logical inference, agent can deduce new facts from existing evidence. If the rules are correct and the evidence is valid, the inference is guaranteed to be correct. So this leads to logical reasoning that's far more reliable and intelligent than simple reactivity. However, reasoning can be complex, so it may involve rules activated at different times, conflicting inputs and long chains of logic. Okay, so this is what makes AI both powerful and challenging, that is making decisions not from direct instructions but from understanding. So knowledge-based agents form the backbone of intelligent systems like expert systems in medicine, logic-based decision makers in cybersecurity, diagnostic tools in engineering, and even planning modules in autonomous robots. So they are what transform AI from being reactive to being reflective and rational. Okay, so thank you.